So we'll read the third night and the fourth night. The third night. In time, Robert grew accustomed to dreaming of the number devil. He even came to looking forward to it. True, he could have done without all the know-it-all attitude and his temper tantrums. You could never tell when he'd blow up and yell at you. But it was better, so much better, than being swallowed by slimy fish or sliding down and down into a black hole. Besides, Robert had made up his mind to show the number devil that he was no fool. You have to put people like him in their place. Robert thought as he got ready for bed one night. The big ideas he had about himself, and all because of zero. He wasn't much more than a zero when you got down to it. All you had to do was wake up and he was gone. But to put him in his place, Robert had to dream of him. And to dream of him, he had to fall asleep. And Robert suddenly noticed he was having trouble doing so. For the first time in his life, he lay awake in bed, tossing and turning. What are you tossing and turning for? All at once, Robert realized his bed was in a cave. There were weird paintings of animals on the stone walls, but he had no time to study them because the number devil was standing over him, twirling his walking stick. Rise and shine, Robert, he said. Today's our division day. Must I? Robert asked. You might have at least waited until I was asleep. Besides, I hate division. Why? When you add or subtract or even multiply, things come out even. What bugs me about division is that you get this remainder. The question is when? When what? When you get the remainder and when you don't. That's what counts. You can tell just by looking at them that some numbers can be divided evenly. Right. Like even numbers, which can all be divided by 2. No problem. I'm pretty good at threes as well. 9 divided by 3, 15 divided by 3, and so on. It's like multiplying in reverse. 3 times 15, 3 times 5 is 15. Becomes 15 divided by 3 equals 5. I don't need a number devil for that. I can do it on my own. Robert should have said that. The number devil, his mustache quivering, his nose reddening, his head growing bigger and bigger, jerked Robert out of bed. What do you know? The number devil shouted. Just because you've learned the multiplication table, you think you know all there is to know? Well, you know nothing. Nothing whatsoever. There he goes again, thought Robert. First he drags me out of bed, then he hits the ceiling when I tell him I can do division. Here I come to a rank beginner out of the goodness of my heart, and no sooner do I open my mouth, he starts making wisecracks. The goodness of your heart, Robert cried. All things being equal, he would have upped and left. But how do you up and leave a dream? He looked all over the cave, but could find no way to leave. What are you looking for? A way out. If you go now, you'll never see me again. I'll leave you to choke on Mr. Brockle's pretzel problems, or die of boredom in his class. Robert knew when he was licked. I apologize, he said. I didn't mean to offend you. Good, said the number devil. His anger subsided as quickly as it had come. Now, 19. Try 19. See if you can divide it without a remainder. Robert thought and thought. The only way I can come up with, he said at last, is to divide it by 19, or into 19 equal parts. Doesn't count, the number devil replied. It's too easy. Or divide it by 0. Out of the question. Out of the question, why? Because it's forbidden. Dividing by zeros is strictly forbidden. What if I did it anyway? Then all mathematics would come apart at the seams. He was about to lose his temper again, but he managed to pull himself together. Tell me, the number devil said, what would you get if you divide 19 by 0? I don't know, maybe 100 maybe, or 0, or anything in between. But didn't you just say when we were talking about threes that division was like multiplying in reverse? If that's the case, then 3 times 5 equals 15, means 15 divided by 3 equals 5. Well, now try that with 19 and 0. 19 divided by 19 divided by 0 is, say, 19. And in reverse, 19 times 0 is 19. Or 19 times 0 is 0. You see, no matter what number you take, you always get 0, which means you must never divide a number by 0. Okay, said Robert, I give up. But what do you do with the 19? No matter what number I divide it by, 2, 3, 4, 5, 6, 7, 8, or 9, I get stuck with the remainder. Come a little closer, said the number devil to Robert. I'll tell you a secret. Robert leaned so close to the number devil that his mustache tickled his ear. There are 2 types of numbers, he whispered. The garden variety, which can be divided evenly, and the rest, which cannot. I much prefer the latter. You know why? Because they're such prima donnas. From the very first, they've caused mathematicians no end of trouble. Wonderful numbers, those, like 11, 13, or 17. Robert couldn't get how blissful the number devil looked. He might have had a piece of chocolate melting in his mouth. Now tell me, dear boy, what the first prima donna numbers are. 0, Robert said to get up his dander up. 0 is forbidden, the number devil shouted, brandishing his walking stick. All right, then. 1. 1 doesn't count. How many times do I have to tell you? Okay, Robert said. Calm down. 2, to begin with, because like all prima donnas, it can only be divided by 1 in itself. And 3, or at least I think so. Not 4. We've been through that. 5 for sure. 5 isn't divisible by anything. And so on. Ha! What is that supposed to mean? He said, rubbing his hands together, a sure sign he has something up his sleeve. The wonderful thing about prima donnas is that no one knows they're so on. No one but me, of course. And I won't tell you. Not even your friends? Nobody, never. The thing is, you can't know whether a number is a prima donna or not by merely looking at it. No ordinary mortal can know without testing it. How do you test it? You'll see, he said, and started scribbling all over the wall of the cave with his walking stick. This is what it looked like when he was through. Now take my stick, young man, and tap every number that isn't a prima donna. That will make it disappear. But there's no 0, Robert complained. No one. How many times must I tell you? 0 and 1 are unlike all other numbers. They are neither prima donnas nor ordinary kind. Don't you remember what you dreamed back in the very beginning? That all numbers come from 1. And then later we saw the need for a 0. Whatever you say, said Robert. Anyway, first I'll tap the even numbers because they're all divisible by 2. That's easy. All the even numbers but 2, the Neville Devil warned him. Don't forget, 2 is a prima donna number. Robert picked up the stick, and in no time flat, the wall looked like this. Now do 3. 3 is a prima donna number, but the rest of the numbers in the 3 column of the multiplication table, 6, 9, 12, etc., are not, because they can all be divided by 3. When Robert had taken care of the 3's, the following numbers were left. Now 4, said Robert. No, we don't need to bother about numbers divisible by 4, they're all gone because 4 isn't a prima donna number. 4 is 2 times 2. But 5 is a prima donna number. Not 10, though, which is gone because it's 2 times 5. And you can tap all the ones that end in a 5, right? Right? You can tap all the ones that end in a 5. Right. Robert was hitting his stride. We can forget about 6. 6 is 2 times 3. But 7 is a prima donna number. Good for you, the number devil cried. 11 is 2. And what others? That, my dear readers, is a question you yourselves must find the answer to. Copy the chart and go on tapping until only the prima donna numbers are left. Let me give you a hint. There are exactly 15 of them in the chart. No more, no less. Well done, Robert, said the number devil, lighting his pipe and chuckling to himself. What's so funny? It's not so hard if you stop at 50, he answered with a wicked grin and settling into a comfortable cross-legged position. But what if you have a number like 10001 or 1414213562237 or 307? It isn't like prima donna, or is it? Or is it a prima donna, or isn't it? If you knew how many mathematicians have racked their brains over the issue, why, even the greatest number devils have come to grief over it. But I thought you said you knew the ands and so on of prima donna numbers, and you just didn't want to let me in on it. Well, maybe I overstated my case a little. I'm glad you can admit you're not perfect, said Robert. Sometimes you sound less like a number devil and more like a number dictator. The more simple-minded number devils use giant computers. They keep them running for months on a stretch. The trick I taught you, taking care of the 2s, 3s, and 5s first, is an old hat, really. Not that it doesn't work, but when the numbers start getting really big, you know that there's no end to them. We have to make them grow bigger than the universe by adding, multiplying, or hopping. And hopping. Now there are all kinds of more sophisticated ways of doing things. But clever as they are, they don't seem to get us very far. That's what makes them so devilishly interesting. And what is devilishly fun, don't you think? And so saying, he twirled his stick with a great relish. Yes, but what's the point of it all? Asked Robert. You do ask stupid questions. The world of numbers is never so musty as your Mr. Bockel, Mr. Pretzel, makes it out to be. Luckily, you've got me to initiate you into some of the secrets, like this. For instance, take any number larger than 1 and multiply it by 2. 222, said Robert. 2 times 2 is 444. Between the first and second number, there is always, and when I say always, I mean always, at least one prima donna. Are you sure? 307, said the number devil, but it works with gigantic numbers too. Where do you learn these things? You haven't seen anything yet, he said, savoring Robert's curiosity. Nothing could stop him now. Take any even number, any one at all, so long as it's larger than 2, and you can find 2 prima donnas that add up to it. 48, said Robert. 31 plus 17, said the number devil without blinking an eye. 34, said Robert. 29 plus 5, said the number devil without even taking the pipe out of his mouth. And it works all the time? Asked Robert, amazed. Why? How come? To tell you the truth, the number devil said, his forehead wrinkling. and his eyes looked upward at the smoke rings he was blowing. I wish I knew. Nearly every number devil in my acquaintance has tried to come up with an explanation. It always works, but no one knows why. Pretty nifty, Robert, thought Robert. He laughed and said, well, I think it's great. But what he really thought was great was that the number devil had told him the inside story. For a while, the number devil had a rather crotchety expression on his face, as he always had when he didn't quite know what to do. But when he heard Robert laugh, he laughed too and started puffing on his pipe again. You're not so stupid as you look, my boy. I'm sorry I have to leave you, but I've got a few more mathematicians to visit tonight. I get a kick out of torturing them a tad. With that, the number devil began to grow thin, not so not so much thin as transparent. And suddenly all that was left of him was a cloud of smoke and a scribbling on the wall. Then the wall started swimming before Robert's eyes, and the cave felt as soft and warm as a blanket. Robert tried hard to remember what was so wonderful about prima donna numbers, but his thoughts were all white and cloudy like a cotton mountain. He had rarely slept so long. And let me show you one last trick. If you haven't dozed off, that is. It works with odd as well as even numbers. Think of a number, any number, so long as it's bigger than 5. 55, say, or 27. You can find prima donna numbers that add up to them too. Only instead of 2, you'll need 3. Let's use 55 as our example. 55 equals 5 plus 19 plus 31. Now try 27. It also works. You'll see, though I can't explain why. The fourth night. The places you dragged me to, a cave with no opening, a forest with ones for trees, and mushrooms the size of an armchairs. What about today? Where am I anyway? At the beach, can't you tell? Robert looked around. White sand far and wide, the number devil perched on an overturned rowboat, the surf rolling in behind him, and not a soul in sight. I bet you've forgotten your calculator again, the number devil said. Look, how many times do I have to tell you I can't take all my stuff to bed with me at night? Do you know what you're going to dream the night before you dream it? Of course not, the devil answered. Still, if you dream of me, you can just as easily dream of your calculator. But no, I've got to come up with one by magic. I've got to do everything for you. And then you complain it's too soft, it's too green, it's too sticky. It was better than nothing. All right, I'll try, said the number devil. He raised his wand, and a new calculator appeared before Robert's eyes. If the last one was like a frog, this one was soft, furry bed or sofa, and gigantic. And one end was a little board with fur-covered number keys, but the screen for the numbers stretched the entire length of the backrest. It was one weird calculator. Now enter 1 divided by 3, the number devil ordered, and see what you come up with. Robert punched the keys. The following answer came up in green on the long screen. 0.3333333333333333333. Doesn't it ever stop? Robert asked. Of course it does, the number devil answered. It stops where the screen stops. And then what? Then it goes on. You just can't see it. But it's always the same. 1 3 after the next. How boring. Right. And dumb too. It's much easier to write 1/3. Then I don't have to worry about all those 3's creeping up. True, said the number devil. But then you've got to deal with the fractions, and fractions, if I'm not mistaken, are something you can't abide. If 1/3 of 33 bakers can make 89 pretzels in 2.5 hours, Then how many pretzels can 5 3/4 bakers make in 1.5 hours? No, no, anything but that. Give me decimals anytime, even if the numbers never end. I'd just like to know how all those threes are doing there. Simple. The first three after the dot means 3/10, the second three means 300ths, the third three means 3,000ths, and so on. And you can take it from there on your own. 0.3, 0.03, 0.003, 0.0003, 0.00003. Get it? Good. Then try multiplying everything by 3. The 3, the 3/10ths, the 300ths, and so on. No problem, Robert said. I can do that in my head. 3/10ths times 3 is 9/10ths. 300ths times 3 is 900ths. 3,000ths times 3 is 9,000ths. 3/10,000ths times 3 is 9/10,000ths. Good. Now what happens if you add all the nines together? Let's see, 0.9 plus 0.9 plus equals 0.99, and 0.99 plus 0.009 is 0.999. Nines down the line. I bet you could keep doing that for like that forever. Right, you are. Though, if you think about it, there's something fishy going on, because 1/3 plus 1/3 plus 1/3 equals 1, doesn't it? Because a third multiplied by 3 equals a whole. Always has, always will. Well, what do you think? I don't know, said Robert. Something is still missing. 0.999 is nearly 1, but it doesn't quite get there. That's the point. That's why you've got to keep the nines going and never stop. Easier said than done. Not for the number devil. With another little chuckle, he waved his walking stick, and the twinkling of the eye in the sky was filled with an endless chain of purple nines slithering higher and higher. Stop! Robert shouted. Please stop. You're making me sick. A snap of my fingers and they're gone. But not until you admit that the chain of nines behind the 0, if it goes on forever, will turn out to be equal to 1. Meanwhile, the chain had kept growing, and the sky slowly darkened with nines. Robert was now as dizzy as he was nauseous, but he refused to give in. Not on your life, Robert shouted. No matter. How many nines you add to the chain, there will always be something missing. The last 9. There is no last 9, the devil furiously shouted back. Robert no longer jumped out of his skin each time the number devil lost his temper. By now he knew that whenever it happened, there was something interesting coming up, something the number devil couldn't easily explain. But the chain was flapping dangerously close to Robert's head, and he was wound so tightly round the number devil that so much of him had receded from view. All right, said Robert, I give in, but only if you get rid of the nines. It's about time, said the number devil, raising his stick, which now had several layers of nines entwined around it. Then he mumbled some gibberish to himself, and the chains disappeared in a flash. Phew, said Robert. Does it only happen with 3s and 9s, or do other numbers make such awful chains too? There are chains as endless as sand on a beach. How many would you say there are between 0.0 and 1.0? Robert thought long and hard. An infinite number. As many as between 1 and till the cows come home. Not bad, said the number devil. Quite good, in fact. But can you prove it? I can. Show me. All I have to do is write 0 and a dot, said Robert, and a 1 after the dot, then a 2 after that, and so on, and I can keep going. I'll have to put all the numbers that have been written after the dot before I can come to a 0.2, whole numbers are whole numbers all. Of course, all whole numbers. Every number between 1 and bazillion can have a zero and a dot before it, and every one of them is less than 1. Splendid, Robert. I'm proud of you. But proud as he was, he could not leave well enough alone. He had a new idea. Many of your numbers after the dot have an interesting life of their own. Would you like to see what I mean? Oh, yes, said Robert, just so long as it won't cram the beach with famous numbers. Don't worry, your big calculator will take care of them. All you need to do is enter 7 divided by 11. Robert didn't need to be told twice. 7 divided by 11 equaled 0.636363636363636363. Hey, what's up with all those 63s? I bet it goes on forever. You bet right. But that's nothing. Try dividing 6 divided by 7. So Robert entered 6 divided by 7. 0.5 or 857 The same numbers keep coming back, he cried. 857 over and over. It's like spinning in a circle. They really are fantastic creatures, numbers. In fact, there's no such thing as ordinary numbers. Everyone has its own features, its own secret. You never completely understand what makes them tick. That chain of nines after the 0, for instance, all those nines and you still not quite a 1. And there are many others that behave even worse, that they go off on the deep end after the 0. They are called unreasonable numbers. And the reason they're called that is because they refuse to play by the rules. If you have another moment for me, I'll be glad to demonstrate. Robert knew by now that whenever the number devil made a point of being polite, he was in for something. But he was so curious he couldn't resist. Fine, please do. You recall our hopping game, I'm sure. What we did with those 2s and 5s and 10s? 10 times 10 equals 100 or 1,000. 10 times 10 times 10 equals 1,000, which we write as 10 to the third power equals 1,000, which is faster. Right. When we hop with the 2, we get 2, 4, 8, 16, 32, and so on, as always with our little tricks, till the cows come home. Well then, the number does said, how much is 2 to the 4th? 16. Pretty good, eh? Perfect, my boy. Now let's do the first hop in reverse, hopping backwards, so to speak. Only when you go backwards this way, you don't really hop. We call it taking a rhubarb, as if we were pulling one of those fine root vegetables out of the ground. So what is taking a rhubarb for? 2. Right. Taking a rhubarb is the reverse of the first hop. So a rhubarb of 100 is 10. A rhubarb of 10,000 is 100. What's the rhubarb of 25? 25, said Robert, is 5 times 5, which makes its rhubarb 5. Keep it up, Robert, and you'll be my apprentice some day. A rhubarb of 36 is 6. A rhubarb of 5,929. Are you crazy or something, Robert shouted. How do you expect me to do that one? Mr. Bronco plagues us enough with dumb problems in school. I don't need them in a dream about them. Calm down, said the number devil. Little problems like that are what pocket calculators are made for. Pocket calculators? This thing's as big as a couch. Be as it may, you'll notice it has a key with a sign on it that looks like this, which means a rhubarb. Right. Now give it a try. Rhubarb 5 9 29. Robert did as he told and immediately read the following off the backrest of the couch calculator. 77. Fine. Now hold onto your hat and try the rutabaga of 2. Robert did as he was told and got the following. Drat, he cried. It's utter gibberish. Number stew. I can't make heads or tail of it. Nor can anyone else, my dear boy. What's the point? A rutabaga of 2 is an unreasonable number. Is there a way of knowing how it goes on? Because I have a feeling it does. You are right, but I'm afraid I can't help you there. Taking a number any farther would mean running myself or a calculator into the ground. Wild, Robert said. A real monster. But write it like this. A rutabaga of 2. And butter wouldn't melt it in its mouth. So, well, let's try something a little less daunting. He drew these few figures on the sand, and they look like these. Count out the small box inside the square and tell me how many is special about it. 1 times 1 is 1 squared equals 1. 2 times 2 is 2 squared, which equals 4. 3 times 3 is 3 squared, which equals 9. 4 times 4 is 16, or 4 squared, which is 16. You do, I bet. They're all happy numbers. Right. You see how it works, don't you? Count the number of boxes on each side of the square, and you've got the number to hop with, and vice versa. If you know how many boxes the square has, 36, and you take the rutabaga of it, you get how many boxes are on each side. Great, said Robert. But when was got to do with unnecessary, unreasonable numbers? Well, squares are wily beasts. They never trust a square. They may look innocent, but they are full of tricks. Take this one, for instance. And he carved a perfectly ordinary empty square into the sand. Then he put a red ruler out of his pocket and laid it diagonally across it. Now, if each side of the length is 1 what? Inch? 1 foot? Robert interrupted. It makes no difference, the number devil said impatiently. 1 whatever you please. Call it Quingen or Quang for all I care. Now tell me how long the red line is. How should I know? Rutabaga of 2, shouted the number devil triumphantly. How did you get that? Robert asked, who was starting to feel overwhelmed. Don't worry, said the number devil. We'll come to it. All you have to do is place another square over it at an angle. He pulled up 5 more rulers out of his pocket and laid them in the sand, which made the figure look like this. Now guess how big the red square is. The one at an angle to the black one. I have no idea. The red square is exactly twice as big as the black one. If you shift the lower half of the black one into one of the 4 corners of the red one, you'll see why. It reminds me of a game I used to play when I was little, Robert said. Heaven and Hell, we called it. We would fold a sheet of paper into sections, paint one red and one black, and open it to black, and you were in heaven. Open it to red, and you were in hell. And do you see that in this instance, there is twice as much red as there is black? I do. Good. Now, since the area of the black square is 1 times 1 quig, we agreed to call the length of each side a quag. Remember? We can write it 1 squared, and if the red square is twice as large as the black one, what's the area? 2 times 1 squared, said Robert. In other words, 2. Correct. Now, how long is each side in the red square? I'll give you a hint. All of it takes a backwards hop. I see, said Robert, the scales falling over his eyes. Rutabarg. You need to take the rutabarg of 2, which brings us back to our cockeyed, totally unreasonable number of 1.414213 ... Stop, stop, Robert said quickly. You'll drive me crazy if you keep on with that number. It's not so bad at all as all that, said the number doll, but we don't need to work it out. Just don't go thinking that unreasonable numbers are a rarity. Quite the contrary. Take it from me, they're like sand on a beach, more common even than any other kind. But there is an infinite quantity of other kinds, the ordinary numbers. At least that's what you've been saying and saying and saying, because it's true, believe me. It's just that there are many, many, many more unreasonable ones. More than what? More than an infinity quantity? Exactly. Now you're going too far, Robert said in no uncertain terms. I refuse to believe it. More than infinity? Nothing is more than infinity. That's a lot of malarkey. That's what it is. Want me to prove it? Asked the number devil. Want me to conjure up all the unreasonable numbers at once? No, anything but that. The 9 chain was bad enough. Besides, what kind of proof is magic? Blast, the number devil said. You've got me there. But he didn't seem terribly annoyed. He merely frowned and started thinking hard. I could probably come up with another proof, he said at last, but only if you insist. No, thank you, said Robert. I've had enough for today. I'm beat. If I don't get a good night's sleep, I'll be in for it tomorrow at school. I think I'll stretch out on your calculator if you don't mind. It looks awfully inviting. Be my guest, said the number double as Robert lay down on the fleecy, furry, couch-sized calculator. You're asleep as it is. You learn best when you sleep, and he tiptoed off as to not awake him. Maybe he's not so bad after all, Robert thought. In fact, he's pretty cool. Robert slept peacefully and dreamlessly, late into the morning. He had completely forgotten the next day was Saturday, and on Saturday, of course, there was no school.